Hello dear friends, welcome to this video. In this video, we're going to discuss about the concept of principal value branch in inverse trigonometry. Before we start, let's think about and discuss about what is inverse function. The definition of inverse function goes like this. If I have a function f from x to y such that my f of x is equal to y and this function f is a 1 1 and an onto function, then we can get a unique function g from y to x such that my g of y is going to be x, where the small x is from the domain of f and small y is from the codomain of y. So if your function is both 1 1 and onto, then there exists a function which works in the reverse or the inverse way. If f of x is equal to y, then g of y is equal to x. Then this function g is called inverse of f, and this function g is then denoted by f inverse, since it works in the inverse process. Right? So the inverse function exists when your function is both 1 1 and onto. But when do we say the function is onto? For function to be onto, the range of the function should be same as a codomain. And which is very much simple. We consider the codomain as only. We consider only the part of the range as a codomain to make the function onto. But for the function to be 1 1, the condition is your distinct input should give you the distinct output. That means two different points should always give you two different outputs. For two different points, you should never get a same output. The output should never repeat for any different point. That is the meaning of 1 1. And when the function is both 1 1 and onto, we say the function is bijective. So for a function to have an inverse, it should be bijective. This is a necessary condition, right? To get the inverse, the function should be bijective. That is a basic requirement for the inverse, right? So after understanding when the inverse function is possible, let's talk about the inverse function in the trigonometry. The first trigonometric function that we all have studied is nothing but the sine function. And something that we know about the sine function is sine function has its domain. The sine function has its domain all its real number, and the codomain, or we say the range, is from -1 to 1. Right? It is only from -1 to 1, it's its range. Since it's taking the input at all real number, it is going to be its domain. And the second thing that we know about the sine function is it is periodic in nature. That means it is going to repeat its value after a definite interval. And if you draw the graph of the sine function, it will look like this. From the graph, what we know is it is taking the value 0 at so many places. It takes a value at 0, at pi, at 2 pi, at minus pi, and again it is keep taking this value at infinitely many places, as it is periodic in nature. Since we know it is covering all the points from -1 to 1, our function is definitely an onto function. It is definitely an onto function. But since it is repeatedly taking a value at many different points, it is taking the same value, so the function is not 1 1. Since it is not 1 1, it is not going to be bijective now, and hence it cannot have inverse. But to create the inverse of this kind of periodic function, what we do is we restrict our domain in such a way that our function become 1 1. How we can restrict the domain? We need to think about only that much part as a domain in which the sign will not repeat its value. So for that, if we observe the graph from this minus pi by 2, if we just go from this point, it continues till pi by 2. After that, it will start repeating its value. So if I continue further than this, it will not become 1 1. Since 1 1 means it should not repeat its output again. So from minus pi by 2 to pi by 2, if I just consider this much as my domain and remove rest of the part, if I just remove rest of the part, only if I consider this much, then my sine function, then my sine function considered from minus pi by 2 to pi by 2, and this goes to the range from minus 1 to 1. Now this sine function is going to be 1 1 as well as onto. So this function will definitely have an inverse. Why it is 1 1? Because we can see it is never repeating its value. Why it is onto? Why it is onto? Since it is covering all the value from the minus 1 to 1, so codomain and range are equal. Since now my function is both 1 1 and onto, I can have the sine inverse. The inverse function is totally inversing both the things, that is domain and the range. So now my domain is from minus 1 to 1 and my range will be from minus pi by 2 to pi by 2. What do we see over here? We see that to make the function bijective, we need to restrict our domain. The one question that arises in student mind is, sir, you only consider minus pi by 2 to pi by 2. You might consider something else. Will it work? The answer is yes. If we see the graph again, and if I consider pi by 2, if I consider pi by 2 to this 3 pi by 2, if I consider pi by 2 to 3 pi by 2, that will also work. Similarly, 3 pi by 2 to 5 pi by 2, that will also work. Similarly, minus pi by 2 from this minus 3 pi by 2, right? This will also work as my domain of the sign. So what do we learn over here is there are different possibilities. Few possibilities I write over here: minus 3 pi by 2 to minus pi by 2. The other probability that we have seen that will work is pi by 2 to 3 pi by 2. Also something else that can work is nothing but 3 pi by 2 to 5 pi by 2. This all different possibility, etc., etc., these are known as a branch over here. All the possible domains from which can make the sine function invertible are known as a branch of. Out of so many branch, the first branch that we have considered, that is this minus pi by 2 to pi by 2, this is known as a principal branch. This is known as the principal branch, right? By consider that as our domain, we can create a sine inverse function that minus pi by 2 to pi by 2 is known as a principal branch. We have different, and among those, one has been considered as a principal branch, right? And without considering this branch, we cannot have the inverse. Hence, it is necessary to consider the trigonometric function on one of the branch to have the inverse. And one of the branch that we selected standard is known as a principal branch. Most commonly, we use minus pi by 2 to pi by 2 for the signs, which is known as a principal branch. Similarly, the concept that we apply over in sine, the same concept can be applied in cosine. If we see cosine having the similar property, if you consider cos function, it has its domain from real numbers and its range going from minus 1 to 1. And if we see the graph of the function looks like this. And if similarly I make an argument over here, what do we know? This Cos function in general is onto since it's cover everything. But this is not 1 1. Since the function is not 1 1, it cannot have inverse. To make the function 1 1, what do we need to consider? We need to consider one of the branch. That means one of the segment of the domain. What segment do we consider over here in general is the thing. But starting from 0, if I consider it is taking all the values till pi. It is covering from 1 to minus 1. After that, it will start repeating its value. So, what do we do here is we consider the cos function from 0 to pi going to minus 1 to 1. Now, this function is going to be onto since it's covering from minus 1 to 1 and it is 1 1 as well. So, since it is both 1 1 and onto, now the inverse has been possible. Cos inverse will be the function from minus 1 to 1 going to 0 to pi. And over here, this 0 to pi is known as a principal branch. What are the other different branch possible? You can even consider from pi to 2 pi, from 2 pi to 3 pi. Even you can consider minus pi to 0 as well. All of them are different branches. Out of this, standard is which we consider in most of the general cases is 0 to pi. Hence, the 0 to pi is called as a principal branch of cos function. Similarly, for all the trigonometric functions, since they are periodic in nature, to have their inverse, we need it to be 1 1. For make it 1 1, we consider one of the branch which is called as a principal branch, and list of all the principal branches are over here. For the sine, as we consider sine inverse, the principal branch is minus pi by 2 to pi by 2. For cos, as we discussed, it is from 0 to pi. And by using the similar argument, we can say that for cosec inverse, the principal is going to be from minus pi by 2 to pi by 2, excluding 0. For sec, it is going to be 0 to pi, excluding pi by 2. For tan, it is going to be minus pi by 2 to pi by 2, where the interval is open-ended, and similarly for cot it is going to be 0 to pi in the open interval, right? So at the end, what I wanted to conclude is we required branch to have the inverse of trigonometric function. The branch which we consider most general is known as a principal value branch, without which we cannot have the function to be 1 1 to make it inverted. Hence, the principal branch is going to be the important concept for making the trigonometric function invertible. I hope you understood the concept of inverse as well as the principal value branch in this trigonometric function. Thank you so much for watching this video till the end. If you understood the concept, like, share and subscribe to the channel. Bye bye.